Welcome to this tutorial on Expect and Actual in Kotlin Multi-Platform. This is one of the most powerful mechanisms that allows you to write platform-specific code while maintaining a shared codebase. By the end of this video, you'll understand how to leverage this feature to handle platform differences elegantly. When building multi-platform applications, you quickly run into a fundamental challenge. While Kotlin Multi-Platform enables code sharing across Android, iOS, and other platforms, each platform has its own unique APIs and capabilities. For example, getting device information works completely differently on Android compared to iOS. You cannot simply ignore these platform-specific features, as they are often essential for your application. This is where the expect and actual mechanism comes to the rescue. It provides a clean way to declare platform-agnostic APIs in your common code, while letting each platform provide its own implementation. Think of it as creating a contract in your shared code that each platform must fulfill in its own way. The expect keyword declares what you need, and the actual keyword provides the platform-specific implementation. Let's see how this works in practice. In your common main source set, you use the expect keyword to declare a function. Here we have expect fun get platform name returning a string. Notice there's no implementation here, just the function signature. This tells the compiler that every platform must provide an actual implementation of this function. The common code can call this function freely, trusting that each platform will handle it appropriately. Now comes the platform-specific part. In your Android main source set, you provide the actual implementation using the actual keyword before fun. This Android version returns the string Android. Similarly, in your iOS main source set, you provide another actual implementation that returns the string iOS. Each platform provides its own concrete implementation of the expected function, and the compiler ensures all platforms have provided their implementations. The expect and actual mechanism is quite flexible. You can use it with functions that contain platform-specific logic. You can expect entire classes with different implementations per platform. Properties that vary by platform can also be declared as expected. And interfaces that define platform capabilities work perfectly with this mechanism. This flexibility makes it a powerful tool for handling almost any platform-specific requirement. Let's explore a more complex example using classes. Here in Common Main, we declare an expected class named Platform. It has a property called name of type string and a function called getVersion that returns a string. Notice that the class itself is marked with expect, and we're defining the structure that all platforms must implement. This is more powerful than just expecting a single function, as it groups related platform-specific functionality together. Here's the Android implementation of our expected platform class. We mark the class with actual and also mark the constructor, property, and function as actual. The name property is set to Android, and the getVersion function accesses Android's system APIs. Specifically, it returns android.os.build.version.release, which gives us the Android version number. This demonstrates how actual implementations can use platform-specific APIs that don't exist in common code. The iOS implementation follows the same pattern. The actual platform class sets the name property to iOS. The getVersion function uses iOS-specific APIs by accessing UI device.currentDevice.systemVersion. Even though both platforms implement the same structure, they use completely different underlying APIs to achieve the same goal. This is the beauty of the expect and actual mechanism, a unified interface with platform-specific implementations. Let's recap the essential points. First, use expect declarations in your common code to define what each platform needs to provide. Second, provide actual implementations for each platform using platform-specific APIs. Third, remember that the signatures must match exactly between expect and actual declarations. And finally, every platform in your project must provide an actual declaration for each expected one, otherwise your code won't compile. Master these principles, and you'll be able to handle any platform-specific requirement in your Kotlin multi-platform projects.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.